Hello everyone. In today's video, I'm going to talk about SAS hash. The SAS hash actually is not used very often by the SAS programmers. I guess for maybe a couple reasons. One is that they think hash is quite complex, and the second reason maybe they are not even aware of they exist. So today, let's take a look at how hash is actually used at work. Most people use hash as a lookup table. If you don't understand the lookup table, let me give you a little introduction. So lookup table is something basically you need to look something up, right? So let's say you have a count table. Right? A count table, you try to minimize the space the data actually need to use. So you have maybe like a count ID, right? And you have a count status. Let's just put that status, right? So in a table like this, usually you see something like very short, like status could be O, could be O for open, or maybe C for closed, or D for dormant, right? When you first time look at the table, it doesn't make any sense to you because you are not familiar with those code. So you do need a lookup table when you try to produce some kind of reports, right? So in a lookup table, what you see is that you're gonna have a status code, right? And then you're gonna have a description, right? So description, like status code could be O, and then description could be open, right? And then the C could be closed, and D like could be dormant. So there are different account status. So when you produce a report, you need to link the table on the left and to the table on the right. Right? So there are a couple options to do this. Usually in a account table, in a large, let's say a large bank, you have millions of customers, right, for each month. And then let's say you have 24 months of data. So that's lots of records, right? But lookup table can be very small. The status code can be changed, but it will be changed very slowly, right? So you usually will see something like O always there, maybe closed, right? And then like say D for dormant. Maybe someday, like in a few months or a year or so, they may want to remove the D and change something to, let's say, I, right? Like I for inactive, which is something I just made it up, right? So change to inactive, right? So that might be the case, but this part changed very slowly. So when something changed very slowly, what we call them is something called SCD type 2. SCD type 2. Okay. So SCD stands for slow changing dimension. If you aspire to be a data analyst, that's something I strongly recommend you to look into, because you might need it when you read the data. So here's the lookup table. And here's the count table. Again, here has millions of records, and all those records need to look up to this table. So the process can be very slow sometimes when you do like lookup dynamically. So what you want to do is actually you want to load the lookup table into the memory, into the computer memory, not the virtual memory, just the real memory, right? And then when you look up, and you just look up in the memory, which is much faster. That's what hash does. So when you create a hash table, actually you create a table, right? It's not really a table, actually. It's like a tree, if you know what I'm saying. But it's just something that it's gonna load to the memory. It's gonna be very fast, right? So this is lookup table. You load to the memory, and the account table basically use this lookup table, right? So the alternative solution is that you do a full join, actually a left join. So you take this all the data here, you left join, right? Left join, Sorry for the screen. You left join to this table. Left join to this table. So you create a big table, right? You create a big table, but you don't. Sometimes you don't want to really create another big table, right? So it's just basically all you need to do is basically a simple lookup. So the easiest way probably just put this lookup table in the memory, and then run through this data set against this little hash table. This is very efficient. It's really fast, particularly when you find out SAS program taking a long time. When you try to join the table, give it a try. It's not always to kind of speed things up, but it's more often than not it might help you. Right? So just give it a try. Before we get back to the hash thing, what I want to tell you something about lookup table. So when you try to add something like an I here, what you want to do is actually you set this D as something ineffective, right? So in the lookup table, this is actually something beyond the hash, but it's something that we use at work, which is something I want to share with you. It's kind of related to the SCD type 2, right? So in here you will have a effective from date, effective from date, right? And then you're gonna have a effective, because I don't have enough space, so effective to date, right? So when you first time create this lookup table, you're gonna set for today's date. Can be anything, right? Let's say January 1st, 2021, right? And then effective to date you set to 9999 or December 31st, right? And same thing here, right? Here, and here. So when you try to bring a new status, you actually want to set this I as something like from like a new day. Let's say today is January 26, 2021, and to 9999 and December 31st. But you actually want to change this part because this is no longer in use, right? So it's the effective date should be changed to today. Two dates changed to today, which is same as January 26, 2021, because this status is only effective during this time period, but should not be effective in this time period unless you want to update this part again. So this is something that you see at work when you work with lookup table. If you want to know more about it, just read more about SCD type 2. But for this part of lecture, all you need to know is basically just a simple lookup table. You can set this one as a primary key, and this one as a foreign key, right? So the foreign key reference to primary key. Usually people don't do that. In SAS, sometimes they do that in database, sometimes they don't do that. So basically, this is a foreign key and reference to a primary key. So I'm giving you a little bit more information than a basic hash table. So So let's take a look at how we're gonna load this lookup table in the memory, and then how we're gonna use this table to read it, and then getting back the description, which is more meaningful when you generate report. So a hash table, the first part, basically you load to the memory. It's very quick, it's very efficient to search. Most of the time, it's something. This concept is quite similar to a dictionary. So you can read more about it. Here's a link which you can try to understand the hash table and the dictionary difference. But it's not really a big deal here. But it's most time it's efficient. That's something you need to aware. It's not something that's always fast, right? And then the hash table has a key and value pairs. So you have a key, and then you have the values. You have the values, just as same as dictionary. If you are familiar with that concept, except in SAS, they allow you have duplicate keys. I don't really see a practical use of that, but you can have a duplicate key here. So that's why I put a note here. And then the third part is that the hash is only available to the data step that creates it. So you really have to create a hash within the data step. Once you finish creating it and using it, and then the hash will be garbage collected. Garbage collection is basically the same as deleted, right? So those are the major concepts about hash, right? So for the key value pair, so you have a key, right? You have the value, right? So this is very common, even you do Java or Python. So in the key, most often, the nodes is like unique, right? So in the key, you can have a character value as a key. You can have a numeric value as a key, right? Or you can have like multiple values, right? Character, right? Character, or a character numeric, right? Character numeric, right? And then numeric, right? You can actually have more, right? You can have more as a key. So this is concept of key, okay? And the value is same thing. You can have character, you can have numeric, you can have a combination of character and numeric. Again, SAS only has two data types, right? If you could deal with Python, it becomes more complicated, right? So in this, when you search for the key, it's quite fast, right? It's quite fast. So it's using that's why it's called hash. It's using a hash algorithm. So all you need to do is basically pass in the key, and then that will return the value back to you. The key concept you need to remember when you deal with key value pairs is that keys are not sorted. So they are not sorted, right? So just remember that point, right? So key value pairs. So how do you use hash? This looks like a little bit old way of doing programming. So the first thing you do, you have to declare a hash, and then you define the key, right? So basically you're saying, okay, we're gonna start using the hash, right? So let's declare a hash, and then you define what the keys are, right? And then then you define what the data are, right? And then you say, okay, I'm done. So basically that's how you declare a hash. When you declare a hash, you load the hash to the memory, okay? And there are also some other hash methods. For example, add, right? You can add more key value pairs to the hash, or you can try to find it, right? You find by the key, right? You search by the key, and they're gonna find the value. This is actually most often used, right? And then the third one will be output. So let's say you have a lookup table in the memory, you made some changes, right? And then you want to save the output to a SAS data set. You can do that as well. So let's take a look at a practical example. For example, in this code, so I'm gonna have a major table. Well, I call it major. I only have the 4 lines of data, but in the real world you have millions records, right? So I define a data account. Basically, it's a temporary data set. I'm gonna read the account ID as numeric, but usually you put account ID as character, but in this case I just put as numeric. And the second part will be account status. So let's have OOCD, which doesn't really probably not that meaningful to you unless you work in the bank. So this last part will be the balance. Let's say I have for the first account, you have a $100 and $200, $300, $400, and then make that numeric. So basically, this is a account table. So when I want to produce some report, I need to translate this, basically use a lookup table, translate those status to a more meaningful status, right? So what we do here, so this is how you define a hash manually. Define hash manually. Okay. So in the first part, you say, okay, when you read the first record, you define the hash key. If this is very important, right? So this means basically in the line 1, when you read the first line, right? So you define the hash records. If you don't put this line, or you remove this line number 13, you have to remove number 23. So this will create a lot of hash table. In this case, it's not too bad. You only create 4 of them. But again, if you have million records, you have to be very careful. It could be like a memory, overload, right? So this is very, very important part. So line number 13. Okay. So you want to define the status, right? And then before we define the hash key, you're gonna see a little warning in the SAS log, and so that's why you call the call missing, because this hasn't defined yet. So this is something that is pretty standard when you use hash is put there, right? So the first step is actually declare a hash. You just say declare hash, and then you give a name for the hash and put a bracket, and then you want to define the key. So let's say I name the key as account status, and then I define data as status description, and then I say, okay, I finish my definition, so I define done, right? So from the line number 16 to line number 19, you basically finished, declare the hash, and then just you claim it's done. So 4 lines of code, right? But now this hash is quite empty, because all you have is just a definition. So you need to add more key and value pairs. In here they call data, but same thing. So to keep things simple, I'll just add just 1 character, right? So in this, I add a key, O as open, and C as closed, D as dormant. So in this little small hash table, I have O, and I have C, I have D. So basically you can see here as a small table. So this basically, you declare the hash, and you can see it's within the data step, and this part actually lives in my computer memory. So the next step, right? So this is the end. So you only declare this once, right? Claim this once, and so that's why it's equal to 1. So this is the end. Basically match this do end, right? So next step, you read the account table. Right? So this is basically an iterative process. You just go 1 step at a time. So you say, I read the account table. So the account table is basically here on the top, right? So when you read the account table, the first thing you read basically is the first line. So when you read the first line, you go for the lookup table. You go look this up. So this account status, okay, so this account status actually match this account status. If it doesn't match, you have to indicate which value is the key from this table. Since they are perfectly matched, let's try to keep things simple. What it does actually is basically, here's the key, and look up, right? So this table, look up in this table, and return the value to the PDB. So what actually gets returned actually is just the status description. This part looks a little bit strange because it doesn't ask you to add a key in here. Doesn't give you a return value, because it's just a special way SAS is doing it. But this works very well. So you just look up the status, and then you find the key using a hash algorithm, and then return the status, and then return something called a code. So if it is found, if it's zero means it's found. If it's not zero, and then basically return some other number. So I know all those status can be found in this lookup table, so I didn't do any conditions after this. But usually when you work with a count table, you're gonna run a lookup. You may find certain status here. You're not able to find in the lookup table. So in here you might have to put a condition like a if, let's say if RC, right, is not equal to 0, and then maybe you do something with the description, maybe say like NA or unknown. You need to do something with it. You need to do something, and at the end you just need to print the results. So let's look at the program. So in this program, basically this is the first part, same thing as what you see in the PPT. So when you highlight it, right, and then just run this part, you're gonna see, so basically the table just does the lookup and return the status. Return status is pretty straightforward, but again the key part is the line number 13, which is very important. Okay, so this is the first example. The second example is that usually you don't define the lookup table this way, right? You want to put a lookup table in a SAS dataset, but usually you put it in the database, right? So you want to load from external table. You don't want to hard code those status in your SAS code, right? How are you gonna change it next time, right? So in this example, basically I create this data set, right, with different status. The reason I'm using different definition because I want to show you, the final table look different, right? So the count table looks exactly the same. So I define the status lookup table, and I define the new status. Like O for overdue, and D for delinquent, C for close, right? So a new definition. So you want to load this table, and directly into the hash. So when you do that, you need to write the code in this way. The first thing we need to define the code in the PDV. So that how you write if 0. Actually, this is false. So this part is actually never executed in the execution step. Right? If you took my previous class, you know that there are two steps, right? So one is the compile step, and another one is the execution step, right? So when you put 0, so it's never executed in the execution step, but still get compiled in the compile step. So this actually is just compile the data set and load everything they need to the PDV. Load everything you need, TVP. You don't have to remember all the details. Just next time when you use hash table, you need to maybe copy this type of part of code and just paste into the SAS program, make some modification from there, right? And the second part is basically similar to the previous example, except you don't have to load the key anymore. All you need to do is, you declare the lookup table, and you say, I'm gonna read the data from this data set. This data set I put here, just make convenient for you to see the account status and also the status here. So you load the data from this table directly into the hash, but you still need to define the key, which part of data is the key, and which part of data is which part of data is the data, right, the value, and then you say define is done. And the rest of the part basically is the same, In this part, you actually can put more conditions. You can put maybe a where clause. You can only you select a column like you need to use keep and job. So you have a few options. But in this case, I just keep things very short. You can even put some where conditions in here. This is when you load the lookup table into the memory. So I just showed you two ways of creating hash table. Again, the first part, is you just hard code it, but it's not very convenient. And the second part, basically you load from a data set. I think this will be a better solution. And sometimes you load from database, sometimes load from database. Okay, so this is two ways of loading this thing into the hash. Okay, so I'm gonna show you how the second part works. Basically the same thing. It's it's very straightforward. You just come here, right? You highlight it, right? So give a try, and then you run a lookup table. So now I'm going to show you the last part. So the last part, actually, I want to show you a couple of things. The top part basically is the same. So what I want to show you, there's something called a heater, which is not something actually used very often either. So, but what heater does is actually it sorts the hash table. Like I mentioned before, the hash table actually is not sorted. It's not sorted because what hash table is actually, when you have a regular table, you can see something like this, right? So when you search something, you search from the top to the bottom. Search from top. When you create a hash table, actually it's like a tree, right? Which is something I don't want to talk too much here, but basically it's a tree, right? So when you search for something, it goes basically do some kind of traverse, right? There are different ways to traverse those nodes, but this is basically what hash does. Same thing with dictionary. Right? So that's why this is not really sorted. This is really the order of getting the data depends on how you traverse those nodes, right? So this is actually those are ordered, right? So this is not ordered. So but if you want to make hash ordered, actually you don't order this tree. So basically you create another object. In this case they call the heater, right? The heater object, and with certain kind of pointers to different node. So you actually just sort of short here, but then you don't really touch this tree. So you can keep things still fast, right? And then you can also get the effect of keep things ordered. So that's something called a heater. So when you define the heater, you need to define the order either by ascending or descending, right? So you put the order, the ascending or descending, and then you can say declare a heater, right? So this name has to be the same as the hash table name, as it's basically just add one line, right? So you can do the loop when you ordered it. So you can see from here, you go to the first one because it's a descending order. This data actually I sorted by descending, just make things a little bit easier for you to view. So you can see the O. All right, when you go to the first, you're gonna see O overdue, and then you loop it, and then when you do the next, right, you get the first, right, you output it, you can write to the another data set, you write to another data set, and then you do 2 times. So basically the next you go to O and you go to a D, right? And then you jump to the last because it's ordered, you go to the C, right? And then from the C, and because your last is here, right? And then you write a C, and then you go for a previous, basically it's a D. So the right order should be O, D, and C, D. So let's take a look at the program. So so here's the program. I kind of encourage you to give a try. It's up to you. But the first 2 parts I definitely recommend you to give it a try. But the last part is it's a little bit different. So let's try to run this part. Right. So the order, you can see the O, D, and C, D. O, D, C, D. Right. So if you are curious, you can try to understand this part. Again, I don't see this part to be very useful, but it's just just something that is I guess it's good to know. Okay, so I guess I hope you learned something about hash in this video, and I'll see you in next video. Thank you very much.